Hello students, welcome to EPG Pathshala. Today we shall be talking about the different types of orbits followed by satellites. So, the learning objective of this module is to understand the different types of orbits of satellites that are used for remote sensing of Earth's surface features. So, now coming to the concept of orbits, as you have studied in the previous modules, there we came to know about the different types of sensors that are mounted on a platform to view and image the objects and places on the surface of the earth. These platforms could be airborne, for example, balloons, helicopters or aeroplanes, or spaceborne, for example, space shuttle satellites. In spaceborne remote sensing, sensors mounted on board a spacecraft or satellite move around the earth in fixed path known as orbit. This path is generally elliptical and depends on two important factors. The first one is the gravitational pull of the earth and the second one is the velocity of the satellite. During the path of motion of satellite, the time taken to complete one revolution of the orbit is called the orbital period. The path on the earth's surface corresponding to the satellite's motion across the sky is called as its ground track. As the earth below is rotating, the satellite traces out a different path on the ground in each subsequent cycle. As a result, the remote sensing satellites often repeat their path after a fixed interval. This time interval is called as the repeat cycle of the satellite. The spatial and temporal coverage of the earth is determined by the nature of the orbit of satellite. Now, let us have a look at the types of orbits. There are three types of orbits based on altitude, orientation and rotation of the satellite in relation to the earth. These are polar orbits, sun synchronous orbits and geostationary orbits. In general, satellites are placed in any one of the three types of orbits mentioned above. The type of orbit determines the design of the sensor and its instantaneous field of view, which we call as IFOV. As we shall study in the subsequent modules, the IFOV is the area on the earth which can be viewed at any particular moment in time. Thus, there are two earth orbits, low and high earth orbits. Coming to the low earth orbits, they are also called as low level earth observation satellites or LEO. These are the most common orbits for passive sensors in remote sensing that use sunlight as a source of energy for illumination. These low elevation satellites are sun synchronous, that is, they remain fixed with respect to the sun. They are divided into three broad categories, namely polar orbits, near polar orbits and sun synchronous orbits. So, the polar orbits are low earth orbits with an altitude of 700 to 800 kilometers, balancing the acceleration due to force of gravity and the centrifugal force. A polar orbiting satellite is highly desirable for remote sensing applications since it views every part of the earth's surface. Such satellites, they are further subdivided into equatorial orbit satellites, that means whose orbits are within the plane of the equator, and polar orbiting satellites, that means orbits in the plane of the earth's polar axis. An example is polar orbiting environmental satellites, which we also call as POES, that are placed in circular sun synchronous orbits with orbital periods of 98 to 102 minutes. They are launched into orbits at high inclination to the earth's rotation such that they can pass through high latitudes near the poles. So, this figure 1, it shows us an example of polar orbiting satellites where you can see the orbit just above the poles at an altitude of about 500 miles. Now, coming to the near polar orbits, in a near polar orbit, the orbital plane is inclined at a small angle with respect to the earth's rotation axis. As a result, a satellite following a near polar orbit passes close to the poles. Such satellites almost cover the entire earth globally. As you can see in this figure, near polar sun synchronous orbit has been shown and you have three lines in the figure. The first one is showing the direction of earth's rotation shown by black line. The red color shows the direction of the satellite motion while the yellow line shows the ground track followed by the satellite. So, as you can see from the orbit, this red color orbit is very close to the poles, but does not follow the exact polar path. So, we call them as near polar orbits. The next orbit is the sun synchronous orbit. These orbits are designed so that the satellite's orientation is fixed relative to the sun throughout the year, which implies that they cover each area of the world at a constant local time of day. These orbits are usually at an altitude between 600 to 800 kilometers and are used for Earth observation, solar studies, weather predictions and reconnaissance studies. Most of the Earth observing missions such as NOAA polar orbiting meteorological satellites, Landsat, SPOT etc. use sun synchronous satellites in low near polar orbits. Now coming to the advantages of sun synchronous orbits, the first one is that due to low altitude of sun synchronous orbits, the ground resolution is improved. Regular scanning resolution along the ground track is obtained. Further, global coverage of the entire Earth can be achieved. These low altitudes permit both a large ground swath and a good ground resolution. Now, the limitations of these sun synchronous orbits are the poor temporal observation with only one sun synchronous satellite. Although the satellites in sun synchronous orbits pass over polar region on every period, but not the same equatorial regions. Generally used for telecommunication, but these satellites are not used for Earth observations. The limited applications of POES can be done for weather forecasting. Now coming to high level satellites. These orbits are followed by geostationary or geosynchronous satellites that appear to be stationary with respect to the Earth, since they are placed at a very high altitude, maybe close to about 36,000 kilometers, so as to equalize the orbital period of the satellite to that of Earth's rotation. Any sensor on board a geosynchronous satellite views the same area of the Earth at all times. The examples include the communication and weather satellites. Another example is the geosynchronous satellite, that means it is Earth synchronous. So, these satellites are placed into orbit so that their period of rotation exactly matches the Earth's rotation period of 24 hours and rotates from west to east direction. These satellites are placed in highly elliptical orbits with an inclination of 180 degrees to the equator. The orbit followed by geostationary satellites is the equatorial plane of the Earth, and such satellites are positioned directly over the equator, so that it travels in the same direction as the Earth's rotation with the same period of 24 hours. The geostationary orbits are commonly used by meteorological satellites. Some examples include GMS, that is geostationary meteorological satellites of Japan over the Asia Pacific region of 140 degree east. Another example is INSAT, that is Indian National Satellite System of India. Other one is GOES, that is Geostationary Operational Environmental Satellite of USA, that is used for American continents. Other example is Meteosat, which is for European Space Agency and covers region over Europe and Africa. FY2 is for China and is used over the Asia Pacific region. Now coming to the advantages of geostationary satellites for remote sensing. Since the geostationary satellites are placed at a very high altitude, they can view a very large area of the Earth. That means about 45 to 50% at a single instant. Thus, they are ideally suited for meteorological applications. The disadvantages of these satellites are that due to poor spatial resolution pertaining to high altitude, these satellites cannot be used for mapping purpose, and thus they have limited applications at higher latitude areas. So, dear students, to conclude, at the end of this module, you would have gained a general insight about the types of orbits as well as the factors determining the types of orbits. So, we have studied that broadly there are two types of orbits based on altitude, low Earth and high Earth orbits. The low Earth orbits, they are further categorized into polar, near polar and sun synchronous orbits, while the high Earth orbits are categorized into geosynchronous and geostationary orbits. The satellites pertaining to these orbits have various advantages over airborne platforms and sensors, such as global and repetitive coverage with reasonable costing. Thus, these are widely used for research, mapping, monitoring of Earth's features and meteorological applications. Hope you all have learned something new from this module. Thank you.